Hey, hello, welcome to the show. It's me, John Park, and we're here in my workshop for John Park's Workshop. So that's the show. Thank you for stopping by. We've got some people over in the chats. Hi, Johnny Bergdahl, for jumping in the YouTube chat. That's one place that you can come and hang out. If you're wondering where everyone else is in things like Twitch and Facebook and other places, we don't keep an eye on every chat, but the main chat is this one right here. It's our Discord. Head on over there to adafruit.it/discord, and you can look for the live broadcast chat channel. And hello to Andy Calloway, Paul Cutler, Johnny Bergdahl is there as well. That's me, C. Grover, Thin Man, hello. And yikes, Lars. Oh my gosh, it is Lars. Yeah, I don't know where he was at, but look, that's Lars. Do you know Lars? He's just a sloth. He's just murderous. Ooh, look, I am in stereo again. I noticed on the Tuesday show I forgot to save the change I had made, so the mic audio was coming in mono. Sorry about that. I fixed it for the 1-minute excerpt, but for the main live stream, my audio was coming out just one channel. So hopefully I will remember to fix that, because it's a different setup than this show, different file I use. Let's see. What else is going on? The format of the show. What do we have today? I'm going to give you a coupon code that you can use to buy some cool stuff in the Adafruit shop, and we'll take a look at some stuff that's new. I have a recap of that Tuesday show, which you'll notice is in stereo. I have a CircuitPython Parsec. I've got a follow-up on the Air Blaster, Air Cannon project there. I'll do a demo using the full circuit. We'll go over how that circuit's working, as well as I'll give you a little sneak preview of the Learn Guide that I'm working on. I tried to be very, very thorough about the parts, specifications, and sourcing and assembly, since that's actually one of the harder things to find on the internet, is good info about sort of exactly what should I get if I want to put this thing together and have it work. So we'll go over that a little bit. Learn Guide will be, I think, out next Wednesday is my goal. I have it takes actually quite a lot of work to do that type of parts breakdown, so I've been slugging away at that. There are random skulls in the workshop, as Andy noticed. Look at that. That one's just hanging out right there. We'll be playing around with those a little bit. In fact, if you saw the show and tell last night, you'll know what I'm going to do, which is blast some air at that and make it hop around. And actually, on live on air, I want to mess around with some of the timings of the blasting of air and how much we're letting through. So that should be a fun challenge to do that live and see what comes up. Let's see. I've also got another 3D modeling and CAD tips segment that I'm going to do. I got some feedback from some people who had some suggestions for things they wanted to see in that. And I am always looking for more feedback on that since it's a new segment. I don't have any fancy graphics for it or anything like that yet, but I'm putting together essentially a little tips and tricks curriculum for getting into the basics of 3D modeling and CAD for the purposes of fabrication. You know, 3D modeling and CAD are a wide-ranging set of topics, but we'll be focusing on things that you can do if you're building stuff to have 3D printed, to create templates for using power tools to create, for CNC, for laser cutters, that kind of stuff. And I think that'll be it. So let's get started. First of all, as I mentioned, we've got a coupon code. It's Blaster. That is going to get you 10% off in the Adafruit shop. So head on over to adafruit.com. That is that place right there. And here, let me move this. Put that back on my shirt. Boop. That'll get you 10% off in the shop. So head over to adafruit.com. And you can look over in products. Drop down will give you a bunch of different categories. You can also click on the view all for new products or featured products. If we take a look at the new stuff, we've got these cool snap-on enclosures for the Feather RP2040 USB host, which is pretty cool. I think I had one here. Oh, I put it inside. Cool product, that particular Feather. And this is a nice way to button it up for any kind of little hosting things you're going to use it for, like synthesizer stuff, keyboard stuff, mouse stuff, data logging, USB logging, key logging kind of stuff. Only use that for good, not for evil. We've also got these new official Raspberry Pi micro SD cards. And coming soon is going to be that little silicon bumper for the underside of the Raspberry Pi 5, which is pretty cool. We've got a brand spanking new Hakko soldering iron. If you want to get a big, fancy, nice iron, that's an upgrade from the one I have. I have a similar one from going back a few years now. You can get $13 off almost with the 10% off that you will enjoy if you use the coupon code Blaster. You just type that in the coupon code section on the way out. And as always, I'll mention we've got a bunch of freebies. So if you spend $99 or more, you're going to get that free PCB coaster. $149 or more, you get a coaster and a KB2040. $199 or more, you get free UPS ground shipping in the continental United States, as well as the KB2040, as well as the coaster. And if you spend $299 or more, you get a Circuit Player and Express, UPS shipping, the KB2040, and the coaster. All of them stack up, and you can enjoy some spoils there. So. That is the coupon code for today and a little pitch for some neat new stuff. All right, next up, I have a show on Tuesdays where I grab a new product. This is a pretty cool RISC-V chip-based QT Py, a brand new, very low-cost chip. I think we've got the whole QT Py for like $4.95. Anyway, on that show, if you watch it on Tuesdays, you get it for half off, usually, if it's an Adafruit product. And I like to do a demo, give you some features, behind the scenes, coding for it. Here is a little excerpt from this week's product pick, the QT Py CH32V203. The QT Py CH32V203 G6 can use this to flash the chip. This is the output of using Arduino IDE, coding the chip with the chip support that we have and the board support that we have, and then exporting a binary. So I can do WCHISP, flash, and then I'll flash it with the NeoPixel binary and hit enter. You'll see it very quickly, and now it is up and running through this little rainbow cycle. So I'm going to go ahead and flash it this time with an HID keyboard example. I'm going to use this jumper cable just to touch pins A0, 1, and 2, which are working as buttons to type in HID keyboard stuff. So this will just type 0, 1, 2. It is the QT Py CH32V203 G6. Yes, right, that's what it was. Let's now move on to a, let me get set up so we can do a cool little CircuitPython Parsec. This one is based on a question I saw in the forums. Adafruit forums are a good place to go ask questions. Sometimes I patrol through there to see what kind of questions people have in the CircuitPython forums or in some board-specific forums. So post there if you got questions, or of course in Discord. Here we go.
CircuitPython Parsec.
All right. Yep, no audio. All right, hold on. Let's start that again. Thanks for the badoop. That was not a technical error. That was just a me error. Let's see. I'm gonna. Yeah, let's do it this way. Hold on. Just want to get reset up. Perfect. Okay. Audio working? Yes, yes. All right, thanks John W. over in YouTube for letting me know. Same with squid.jpg and Janisco over in the Discord chat. Okay, for the CircuitPython Parsec today, I wanted to show you how you can use external NeoPixels with the Feather Prop Maker RP2040. So here you can see I have the Feather RP2040 prop maker. It's got an onboard NeoPixel and it also has external NeoPixels plugged into its screw terminals. So right now, if I save this code, this is standard NeoPixel code and I'm running through a little rainbow cycle on that onboard NeoPixel. Now if you look at this code, I'm importing board, digital I/O, NeoPixel, and the LED animation library. In the case of the onboard NeoPixel, I'm setting this up as a single pixel connected to the board.neopixel pin. If I go ahead and swap that out for the external NeoPixels, those are on a pin called external NeoPixels, otherwise this setup is the same. When I hit save, nothing happens. That is because for power saving, the external NeoPixel pin and all of the external power pins are turned off by default. So what we need to do is just enable the external power pin. Now if I hit save, you can see we are glowing a bunch of NeoPixels on that little external stick. So the way we do this is we set external power is the digital I/O board external power pin. Direction, it's an output. Value is true. That's it. If you needed to turn that off for reasons of power savings, you can just flip that off in your code with a button or a switch or something else like that. So long as that's turned off, we're not going to draw any power over the external pins. And that is how you can use external NeoPixels with the Feather Prop Maker RP2040. And that is your CircuitPython Parsec.
CircuitPython Parsec.
Yes, indeed. The little glowy thing here, if you're curious about it, these NeoPixels, bare NeoPixels on the camera are always a little bit hard to look at. So I was going to put a piece of our little LED plastic, which is nice. It diffuses it a bit. If you lift that away an inch or two, you get sort of a solid bar almost. Keep going, we get just a big glowing rectangle. I needed something to hold that away from the surface, and I happened to have one of these little lenses that we sell. This is, I think, the plastic lens we sell to put on top of the Hallowing or the monster mask. So I set that, and it actually kind of warps and concentrates the glow into the center of the carefully balanced piece of plastic there, which I thought was neat. So you can do some fun effects by lensing and diffusing your NeoPixels. Think about that as you're planning some of your Halloween haunts, in case you're into that sort of thing. Okay, let me unplug that and get that out of the way. And let's see, next up what I wanted to do is let's talk about I'm going to go into the Learn Guide that I'm working on. This is not published yet, but I'm going to go into this Learn Guide right here for the Air Blaster, because it's actually kind of a nice way to look at the assembly. So if you were with us last week, I had done some of this assembly. I can't remember. I think if I had my solenoid valve, I was triggering it just off of a power supply, and I had no microcontroller involved yet. So this is the tank prep here. So this type of air tank, I have a 5-gallon tank there. You can get larger. That's about the smallest they sell, typically as just an air reservoir type of tank. And one thing I mention in the guide is that if you have an air compressor in your shop with a little 1-gallon tank or a 3-gallon tank, you could use it for some kinds of projects, but you probably just want to leave it alone. Just leave it for your normal uses. One of the keys to this project is removing the valve that comes with the tank and is ported for 1/4 inch usually, and getting to use the flange on there that's for a 1/2 inch. So the tank flange, as you can see in, I'm not previewing this, so hold on. So when I click on stuff, it's in edit mode. Let me see if I can go to preview mode. Here you can see that opening. That's a 1/2 inch. That is going to give us better bang for buck when we use the solenoid valve to blast that through. In fact, I don't know if I've run into smaller than 1/2 inch solenoid valves. They probably exist, but not commonly. So this, we're removing that, just using this to fill it up and then blast it out. So we'll remove the parts that came on there. Next up, I've got let me go into the overview section. I have the links and specifications for every part that you're going to need. So the air tank here, I give you the specs and a link to the Harbor Freight on this. I think most everything that isn't from Adafruit I either got at Harbor Freight or Home Depot, but you may shop elsewhere. Anywhere that has plumbing supplies, you can get most of these parts. So we have essentially 2 sections to this. So the 1/4 inch side, and that's the air coming from a compressor in, and then we have the 1/2 inch side, and that's going from the T to the tank and then on the way out. So I've broken them up into those sections. Here you can see each of these parts that you're going to need, and I showed them here in their packaging because, again, I think that makes it a little easier if you're shopping from stuff to see all the specs and the specific words that they used, at least on these, and then links over on the side. I may also do a McMaster car because those are great, likely to stick around forever, high quality. It's probably going to cost more than getting it at your typical big box store, but I may put together a McMaster cart or something like that makes it easy for people. Or maybe a mix of McMaster and Granger. The 1/2 inch pipe settings side of things, I've got the T, I've got a pipe nipple that goes down to the tank, and then another that comes out the side to go to a shutoff valve. The solenoid comes next after another one of these short pipe nipples, and then the main barrel at the end of that. Tools to mention, you can get away with about half of these, but it's nice to have at least one pipe wrench and a couple of crescent wrenches, adjustable box wrenches, and if you have some that are specific size to what you need, that can make it easier too. But at a minimum, you're going to need to be able to crank down on 2 box wrench size things in 1 or 2 cases, and then grab a hex and grab a pipe with a pipe wrench on the other to really crank stuff down. You can't just finger tight this stuff or it won't have a seal. And let's see, then in the build an air blaster section, I've got the layout. So what you want to do is kind of like what I did last week, is lay these out finger tight, a little bit harder than that even, so that it'll maybe even hold a little air just to test things out before you go and put it together for real. So this is the dry fit, and you can see I'm not putting any thread compound or tape, Teflon tape on there yet, but this just is to kind of do a reality check that you have everything you need and you've got it in the right order. Go to the T, go to the shutoff. By the way, you want a fully ported gas valve here so that it's the hole is a full 1/2 inch, because it's a ball that turns, and you don't want a small hole on that. You want it to be able to let the full volume of air through when you release it. There's our solenoid, which I may have Lamore change this in our product description. This is actually both a liquid and an air solenoid. It works great for both, and I think we have it listed just as a liquid solenoid. But you can use that if you want. So there's the sort of final dry fit layout there. This photo I mentioned, I might just Photoshop in the valve there, but I had put that together before I had the solenoid. And then I give a little bit of info on taping. You want to tape it counterclockwise so that when you thread it in, you don't unwind the tape and bunch it up in there. Overlap it. You can get a nice seal by overlapping by at least half the width of it with each turn around. So there's some of my fittings ready to go. Let's see. Some nice said, my air compressor is great for Halloween because it scares me every time it fires back up. Yeah. If you have an air compressor with the reservoir and it's just set to hold a certain pressure, and maybe it's got a slow leak, or you're just using it every once in a while, it'll just kick on and scare the heck out of you. So it's a self-owned scare. Here you can see me cranking together some parts and just going through those step by step. There's the full assembly, and then we screw it onto the tank. And this is the point where you could test this just with your 12-volt supply, or move on to building the circuit. So right now on the circuit side of it, I've taken the photos, but I haven't uploaded them into the guide yet. But there is the fritzing diagram and schematic of what that is. You can see it's not many parts. We're using the feather prop maker, a feather wing that's the power relay, a DC input jack. I'm using the 12-volt 5 amp power supply that we sell. It's listed in the parts, and then our distance sensor there that we use to trigger it. Solenoid has a electrolytic capacitor on there to just absorb some collapsing electromagnetic field so that we don't reset the board. It will. And at least the way I had mine wired, it just resets the whole board if you don't put a cap on there. It's just such a big electromagnetic noise coming back into the system. Right, so that's the sort of early behind the scenes of the guide there. And now let's get to the thing itself. So I'm just going to put a small down shot in the corner there. And thank you, back EMF, Andy Calloway. That's the name of it. We want to avoid the back EMF. So let's come over here to demo this. So I've got it kind of upside down, so I just have to check. I have about, looks like 60 PSI in there. You can see I've got my compressor line hooked up to it right now. And I'm actually going to change the lighting so this is a little easier to see. There we go. So I've got a compressor on the floor here. I have a cutoff valve so that I don't send the air back to the compressor, especially if I take this off. I don't want to just leak my air out, but I can remove that once it's filled. Regulator here, pressure. This is my second, you can see it in the overhead view, I think a little better. Let me see if I can, let me click back here just so that I can use my camera control. Let's see. So this right here is another cutoff valve. So right now, solenoid won't let any air through because I'm stopping it right here with this shutoff valve. So let's see, I think I've got it all plugged in. Let's demo it just, you'll hear the solenoid click. All right, so I have the distance sensor sitting here. For now, I've just sort of attached it to some magnetic standoffs, which makes it pretty convenient for testing. It could be a final solution too. When I get closer than I think 50 centimeters is what I have it set at, it will trip, and you can see the relay LED lights up there. I've got one of these little waterproof boxes with the cable glands on there, and that has my feather, the relay. They're both on a feather doubler, and then I have my 12-volt supply plugged in for the relay to use, and I have the USB to power the feather. You could also add a battery, but you're going to have to be hooked up to 12 volts, so I just decided to make it simpler, no battery, and I'm just running USB power to the feather. And then the Stemma QT cable running out to my little breakout board there. So with the valve open, you can see when I trip, it's going to do these 3 blasts with a particular timing. Oh, and I'm not pointed at it anymore. Let me aim. Let me re-aim. And I'm going to switch the cameras. There we go. So that's the idea for this kind of using it as this kind of a haunt effect. Is you might have this aimed at some prop nearby, and someone walks through your haunted house or onto your porch, and this it's kind of scary from just the noise. It makes a bunch of noise. But also just the fact that something suddenly moves pretty quickly. It's a type of motion, as Lamore mentioned last night on Show and Tell. It's hard to get that kind of motion using anything else, you know, electric motors and things. It's kind of tricky. Andy Calloway asks, why the 3 clicks? That's just what I set it to, and we'll look in the software. You could have this just do 1 blast. I decided to write a little function that I can tell how many blasts, the duration of a blast, and the timing between blasts. And then you can layer those up to do things like pauses, which is how I have, I'm calling it first to do 2 blasts with the same interval, and then it waits a beat, and then it does that 3rd blast. Now you can use this also just for sound. You can use this to fire off confetti, maybe little paper confetti bats or something like that. Some people use a setup kind of like this with a hot glue gun to spray cobwebs, but that's more for decoration. So this is a little outside of that, but just your regular compressor with this type of little nozzle here you can use rigged to a hot glue gun to spray cobwebs around. And that is it. You can see here I have it actually sort of strapped down to my bench, just because when I fill it up to about 80 psi, it will kick a bit and move the thing. Ideally, you're going to clamp this down. I don't know if you can see it. The welded bracket that comes on this type of air tank has a couple holes in it, so you could bolt it into a surface like a large plank that has some weight on it or something like that, depending on how you're going to use it. Also, you can use other. You can see here I've still got threading on the end that I've left bare. Some people will put a floor flange on there so that they just don't like bump their ankle into this while they're doing stuff. Makes it a little softer. But you could also use like a U-joint to fire the air upward, especially if you're going to attach some other, container to put in confetti or something like that you're shooting off. Yeah, candy floss, says Andy Calloway. Yanisku7 says Synth.io with Air Blaster. Yeah, you can hook this up to this type of thing to MIDI control if you wanted to be able to play MIDI over 5 tanks for different notes. You can make your own pipe organ. You can attach noisemakers. I know people put like a vuvuzela or something like that on the end of these to make a bunch of noise. Let's see, after a bunch of shots like that, I'm getting down to about, what, 25 PSI? 25, 30 PSI. So 5-gallon tank is pretty good. I'm not aiming at my skull again. You can get, I think this is $35 for this tank. You go up to like an 11-gallon tank for maybe 60 bucks or something like that. So depending on your needs, you can have loads and loads of air on hand. If we need to refill this, I'm just going to take my air line here, plug it into the end, open up that. You can see it's actually, since my compressor's not on, it's letting air out this way. So I'll turn on my little compressor. And it'll take maybe a minute to fill to where I want it. You can use this regulator to decide how full, how much pressure you'll allow in. Don't know if you can hear me at all over that, but I think the mic is pretty proximity based. Brrr. That's nice. I didn't have this latched on. I don't know how it was filling. That's dangerous. This just came off. But that is now at 60. And that's why it's helpful to have this cutoff valve. So again, it's pressurized, but with this valve closed here, it's not going to fire off any air. Open that up, and now to get into software land, what I'm going to do is I'm going to unplug the feather that's in there from USB, and I have a long USB extension cable. I'm not going to walk in front of the barrel of that thing. That's not super safe. And I will plug in, let's see if this will reach. There we go. My cable's interrupted it. So I'll plug in the feather over there. Let's go to, how about a main cam there, this there, and I'm gonna move this here. There we go. And if we go over to the code view, okay, good. So this is what I've got running on that feather. So here you can see I'm using this distance sensor, the VL53L1X, so I import that library. I've got a variable here for the trigger distance, how far away does something, or how near does something need to get before it triggers. And then I have a state for whether we're triggered or not, and that just keeps us from triggering over and over and over again until we get away from the sensor. Once the triggered distance is no longer true, then we can flip that triggered state back to false. Here's the I2C setup. There are two different distance modes for ranges of accuracy on that. And I actually don't know what the timing budget is used for. I mean, I can guess is how much of the cycles of that distance sensor are used to check the distance. There's a little bit of diagnostic stuff that I lifted from the sample that just shows up in the REPL, and I'm going to open up the REPL right now. Terminus. Toggle that panel. I like to type in Disco Tool, which prints out the list of boards that are plugged in, so that I don't just connect to the wrong board if there's more than one with a similar name. But here we can say disco tool N feather. That's telling us the distance right now. So I'm actually printing out the range so you can see. Whoa, right there. That's where 50 is. So it's bouncing off of something at 200. I think a little piece of lighting equipment that I have up there. So there you can see that's useful for figuring out your range. Oh, did you see that I'm printing bang? Yeah, that was my initial testing of this. Then I've got a command for the VL53 to start ranging. That says just start doing your range checks. And then I've set up the relay pin just as a digital output, pin 10. There's a solder jumper on the bottom of the power relay to solder so that you can pick the right pin that you want to use for your project. So I picked D10 on the solder jumper underneath the power relay feather wing, and then I'm picking that D10 as my digital out. So whenever that value goes to true is when we're triggering the solenoid. Then here's my little blast function. So I accept 3 arguments, a repeat, how many times to do the thing, duration, how long to keep the solenoid open, and the rate is how quickly to repeat the pause between each blast. So then I in range repeat, I set the value to true, I keep it open for this duration, I set the value to false, and then I pause for the rate. And I set the distance to none initially so that I can do a check on that. And then the main loop right here, if the data ready, so this is just saying, do we have data coming from the sensor? Then we're going to cast the distance variable from the VL53.distance command. And you can see, you can print out that distance. That's what you're seeing right there. The clear interrupt came from the sample. Again, I don't really know what that does, but it sounds important. I'm leaving it in there. It's working. And then I am sleeping a little bit between distance checks. I can actually speed that up right there. And now you can see it will trigger sooner. I had like a half-second pause there, so now I'll keep that a little faster. So if the distance exists, if we get a distance reading from the sensor, the check is if the distance is less than or equal to the trigger distance, which is that variable I had up top, then we're going to go through this process. We'll check, did that triggered state get flipped? No, it's not yet triggered. Okay, good. Then we're going to call my blast function, and that's what's calling it twice at a 0.03 second hold open time with a 0.2 delay between those. And then the reason this goes blam, blam, blam is because I have a time sleep right here just to pause. And then I'm calling blast just a single one more time. I set that triggered state to true, and that's what keeps it from not just going over and over and over again. If I hold my hand there, I have to get away first. If the value is greater than that trigger distance, we can flip the state of triggered back to false. So if we want to test out different things, what I'll do is, how about I'm just going to change, I don't know if this is a reasonable time, 0.01. I don't know if it'll trigger the solenoid that quickly, but it's worth a shot. So I'll hit save. And of course, while you're testing, you could trigger it from code, or you could make a button for yourself, which would be kind of nice. I'm just going to trip the sensor since it's working. It's easy. So let's see what we get from this. Ah, nice. So you can hear it does do a really limited puff, 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 which could be nice for just like a sound effect. Let's do those quicker between them, and let's do a bunch of them. Let's do like 6 of those puffs. bum. So you can do like machine gun sounds and that sort of thing. Maybe you don't have a pirate theme, you have a World War I zombies, undead walking through your front yard kind of theme. Let's do a bunch of those. Let's do 12 of them more rapidly. 0.05. Let's try that. Hopefully you can hear that. I don't know how loud that is on my mic. Actually, let me ask that question before I keep testing that. So someone in the chat, let me know. Can you hear those? Since the skull is not going to be a good indication of these, I can hold up like let me hold up a little cloth in front of it. So I've got a little chamois cloth. So you can see there, I held my hand and kept it there, but it didn't just keep rerunning it, and that's because I have that state variable. That's a lot of fun. Loud, but not so loud that my neighbor calls the cops. Thank you, Abadus. Appreciate that. Yes, can hear, says Andrew Dingnan. By the way, Randy Walks had a really good point. I meant to and did not, and I'm going to update this. He asks, or they ask, if I removed the pressure relief valve. There was a pressure relief valve on that part that I removed. I was planning on reusing that, but I think I didn't have the fittings for that. So I'll probably just get a 1/4-inch pressure relief valve in line there, and that means if you somehow had a failure with that regulator and it let more pressure through than it should, you're not making something that can explode. Hopefully you have a few fail safes. My compressor that I'm running into it can't go as high. It can only go to 100 psi, so I technically with that shouldn't be able to, but if you had some really big, powerful compressor, you could overpressurize this, so it's a really good idea. Thanks for mentioning that, to add a pressure relief valve into the system. So I will get something and add that in, and I'll put that in the guide for sure. Thanks for the reminder of that. I'll check. Maybe I can use the one I pulled off, but I may just get some simpler solution than that rather than the one I'm removing. Let's see, what else should I test? I think that's a pretty good test of things. You can also, let's go to a single blast and dump a bunch of air out. So let's go for 0.1. No, let's go for 0.5, a half a second. This should just like drain a bunch of air out. Let's see what our PSI is at. We're at 20 PSI. This will probably dump half of that out just in a second or a half second. So I'll save that. Maybe it'll move the skull for us. There you go. So nice long blast like that. We're at, yeah, we're close to empty. It almost dumped out the rest of it. But that's cool if you're doing like a single kind of like thing. You run into these kinds of effects with air hits in water at theme parks, that kind of thing. Pretty good also if you have a canister of confetti so that you get, lots of it flying up in the air. So let's see, this will probably really empty it. Here we go, ready? You can hear it dying. No air left. All right. I think that's going to do it for the code on that. Let me know if you have any thoughts or questions. You can, of course, do some, I'm just going to get back to roughly that. This will be my 1, 2, 3. Bum, bum. You can, of course, set up an interface for this if you want. Anything from a couple of different buttons that will reconfigure it, or a dial that'll reconfigure it. You could add a little display, a little TFT display, and an encoder or some buttons so that you can change on the fly without having to change the code in CircuitPython directly. And I've seen some pretty cool prop controllers out there in the sort of semi-DIY haunt market where people aren't going as elemental as microcontrollers and add-ons, but sort of self-contained boxes that have record functions, which is really cool. So you can go into record mode and then go pop, 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 stop record, and then that's what it's going to play back, which is really neat to be able to do it by example. So I'll leave that as an example for the reader. There are some guides we have, I think, already that do that type of code, being able to go into a learn mode, do a thing with timing, and then play it back. And as Janisku mentioned, we could use SynthIO, we could use MIDI, we could use any of a bazillion different cool, fun ways to trigger stuff. All right, so let's move on from that. I'm gonna go back to this view here. And by the way, I have a couple of different control schemes going on today. I've got my shop lights with an old project of mine that flips that switch mechanically with a servo. But then I also have a Bluetooth spotlight that we can use to illuminate Lars over there. So let's go back to regular lighting and not illuminate Lars. And if there aren't any other questions about the Air Blaster, then I'm gonna dive into our last segment. Before I do that, I will remind you, you can get yourself some cool, good stuff from the Adafruit shop using that coupon code. By the way, if you look in the shop for solenoid valve, you'll find this one here, brass liquid solenoid valve. It's actually also good for air gas. That's the one I'm using on this project. We have those in stock. I'm using the Power Relay Featherwing to control it. So this one will allow high enough current at a high enough voltage to flip that on and off. And I'm using the 12 volt, I think it's 12 volt 5 amp, yeah, switching power supply to power that. So those are some things you might want to consider getting, throw in your cart, and use 10% off coupon today with that code right there. It is Blaster. Blaster will get you 10% off in the store. Okay, so last thing I'll do is a bit of a part 2 to the new series of 3D modeling and CAD intro and tips. So let me just get set up for this. Move my windows around so I can see. And let me know if you can see that. As I've mentioned before, unfortunately, for the cursor to show up in this, I get stuttery streaming. If I move to the sort of video game mode where the frame rate is high, it turns off the cursor, unfortunately. I think they think that's a gaming mode feature that you would want. So I'll keep tinkering with ways to do this part of this setup. But quick recap of some stuff we did last week. If we take a look at a typical 3D view of the world, we've got a top-down view, a front view, and a side view, and some sort of exterior camera view, usually a perspective, sometimes parallel, sometimes projection view of the world. And we're working in an XYZ coordinate system, X being horizontal, Y being forward and backward, and Z being up and down. And so we can transform stuff with translation, with rotation on those 3 axes, and with scaling on those 3 axes, 1 at a time, 2 at a time, 3 at a time. So that's the basic transforms of stuff, whatever that stuff is. One of the elemental things to make things from in 2D are curves. So we can go and draw a curve around. You can see it's sort of free form, doesn't snap to any grid by default. I did snap the last point to the first point, so just this notion of being able to either precisely enter dimensions, precisely follow a grid, or precisely inference different landmarks in your model, like the center of a line, the center of a circle, the end of a line, the tangent of an arc or a curve. That's how we can precisely create stuff. I mentioned last week also we can do things like say I want this to be a 50 millimeter line. No matter where I go, that's going to be 50 millimeters, or whatever my coordinates units are. In this case it's millimeters. So there we've created a 50 millimeter line, and we can measure that, we can put dimensions on that. So those are sort of the basic building blocks that we looked at last week. And I talked a bit about splitting and joining things and creating fillets and chamfers. So to continue on with this, let's talk about some of the primitives. You don't always have to make things by drawing them yourself, especially if you know that they should follow certain constraints, like I want 90-degree angles in a rectangle. We can go to creation of primitive objects such as rectangles. We can constrain those to be squares. And we can do 3-dimensional versions of most of these types of primitives as well. So the equivalent of a rectangle there is going to be a box or a cube of some kind. If we look at another primitive that's pretty common to use, we've got a circle, and that can lead us to doing 3D things like a cylinder or a sphere. And then there are some more complicated primitives that have more inputs, such as 2D polygons. So this is an octagon here. When I go to create one of these, we need to tell it some things like, oh, I want this to have 3 sides, and now we can make a triangle. Or I want it to have 5 sides, make a pentagon. Those objects, we don't really have last I checked, I don't think we have a direct line to those in the 3D world. And so that leads us to creating those sorts of things from the 2D curves. So similarly, there are some 3D things, I'm going to switch to a 3D only view, that don't exist as an obvious single 2D primitive. So if you look at I know you can't see this list here, but I'm going to go to something like a cone. This lets us lay down a base diameter or radius and then just a height, and now we have a cone. Or we can do a truncated cone if we want to have essentially a base, a height, and a second radius or diameter there to make that sort of object. So some things like this we can create with a primitive, which is nice. We can create them from a set of 2D primitives as well. So let me clean up some things here and create a similar object from 2D curves. So I'm going to pick one of my existing 2D curves, this circle, and I'm going to duplicate it just by copying and pasting. I'll scale it smaller. So it's similar, not exact, but that's okay. And now I can create a surface using these 2 curves. So I can grab one of them and grab another and I'm going to use a command called loft. You'll probably see things showing up in the upper left-hand corner, a little text there. So I'm typing the names of commands, which means you can see them. It's actually a very fast bit of interface rather than using an icon or a menu. I'm just going to type in the word loft. You can see here it's saying, okay, if you want to create a surface that essentially draws a skin between these two circles, we have to agree on the starting point and the direction. And since I made those two curves by duplicating the first one, they line up for us, which is nice. Otherwise, there's tools to fix those things. And then it's going to give me a dialog box. Again, you won't see this dialog box, but it's asking options on how to make this thing. I like the defaults, so I'm just going to say go, OK. And now I have a sort of hollow version of, let me see, can I target? Sorry, I got to grab a menu item that I can't remember the shortcut for. I'm going to just fix my camera. Move target to object. Okay, that'll allow us to rotate around that neatly. So I have a hollow version of a similar thing here. We can go in kind of piece by piece, and I like showing these kinds of things in early modeling before I show the sort of convenience versions of them. So I can make a planar surface that's just going to be that one planar circle. So I'll do, see me typing up here, planar, and it's, oh, that's wrong. What do I want? Planar surf. Planar surf. Select the planar curve to build the surface. So I'll start with the base circle there. You can see it said, do you want the curve or the surface edge? I'll say, okay, let's grab the surface edge, and I'll hit enter. So that just turned that into a trimmed surface, and I'll repeat that command, pick the top one. And now I have the pieces parts. So it's actually composed of 3 surfaces. We can now pick those and join them together to make one watertight object, which is usually the goal when you're 3D printing, and for a lot of other fabrication things, as well as analysis of objects. If you want to do, ask it to tell you what's the volume of the object, you'll kind of want to be able to stitch stuff up. And we can do things like force it to align seams and things like that, which we didn't here. But that's okay, because in reality, even though you know how to do that now, there are usually convenience commands. I'm going to say cap, and it will just automatically cap that for me in one go. It just finds the open ends and basically does the same sort of planar trimmed surface there to hook that all together. So let's see, that covers, I'm just checking my notes, some of the 2D and 3D primitives there, as well as creating separate surfaces, joining them, and lofts. So the last section I want to do is talk a little bit about some of the uses for curves that will allow us to take curves and then generate 3D objects. So I'm gonna, one second. I'm going to take some of my flat polygon, single line kind of things and draw those. And if I wanted to make a flat to curved to flat surface, we could start with these. And then last week we looked at splitting and joining. So if I say split this with this, and one second. Okay, let's see. So split this with this. We now split this with this. Okay, again, I'm showing you the slow way, but this is sort of what happens under the hood. I can then delete these parts. I can join these, and then I can create a fillet, which is going to be a perfectly tangent arc, actually, a perfectly tangent arc that feeds from one to the other. Tangent means we won't have any little kinks and things. And I can tell it the radius of that. So I'm going to say fillet. Let's do a large radius. I'll do like a radius of 8 millimeters. Each of these little grid lines here is a millimeter. And so now you can see I got this nice, smooth arcing surface. If my surface, or my curve rather, if my curve is more organic than that, or I just want to do it by hand, I'm going to use a different tool that allows for me to place control vertices anywhere I want, and then it fits a curve, a degree 3 NURBS curve through those. If I'm trying to make something like that one there, same way, I'll create some lines to approximate that type of curve. And now we can go in and noodle this. It's not necessarily going to be tangent. It's easy to add little warps and things like that, especially with this diagonal curve here. But similar idea, hand-drawn curve. What I'm going to do actually is take one of those now and make a surface from it. Let's take the kind of jazzier one, and I'll give it a little more style to it there. Okay, so that looks pretty good. I'm going to now create a little reference curve here, and this will make a little more sense in a second, especially when we see this in 3D. I'm going to do a technique that's similar to that loft where I stretched a surface between two curves, except this one is even a little more elemental, a little more simpler, and it's kind of like lathing something on a lathe, or making a piece of pottery on a pottery wheel, and it'll simply allow me to take one curve and sort of drag a skin behind it as it revolves. So this is sometimes called a revolve, sometimes called a loft. There's probably a few other names for it. So I'm going to take this object here and I'm going to say revolve, and then it wants to know the start of an axis. What axis am I revolving this on? That's why I made this little helper line here. I'm just going to click on one end of it and then on the other end of it and hit enter. Oops, I didn't click. There we go. And so now I have the axis that I'm revolving on, and now the sort of next question is how many degrees do you want to revolve, and where do you want to start? So I'm letting it start at the beginning of where my curve is, and I can just hit enter to say let's do it 360, or I can snap to that curve there, or I can go in 90-degree increments by holding the shift key. So there's a bunch of ways you can decide. I'm just going to hit enter and let it do a full 360 turn. So now we have this sort of bell type of object. Again, we can close that by saying cap. And now I've taken a curve and revolved it and capped it to make an object you could 3D print. So maybe this is going to be the foot on the bottom of your box or something like that. You're going to print 4 of these things. And you may want to go add holes in it, stuff that we'll cover another time. Now you've got some options. I'm going to actually delete that. I'm going to turn on history. And now we'll create an active connection between this original curve and the loft that we sweep or revolve. So I'm going to say revolve, start here, end here, enter, enter. And now the curve, you can see these little points on this curve, I can update those, and that will adjust my revolve. So it's sort of a helpful way to change that profile and see what that's going to look like in real time. Make this a little shallower here. This might be helpful to look at from an orthographic view, one of these side or front views. So I can still be shaded here and bring that in, up, make a nice hard curve there. Let's grab that point. Oops. Hey, I've broken history. No, cancel that. Let me go back to wireframe or X-ray. Actually, that'll be a little more helpful because I want, oops, to grab that point right there. Bring that in. So you can see you can have a lot of fun with this, and you can also create a 3D object from just the definition of the most simple piece of it, which in this case is one curve and the axis that we're adjusting it on. questions in the chat. Loft. Why loft? I wonder. Andy Calloway asks. I believe that comes from shipbuilding. I believe defining the ribs of a ship and then creating the surface across it is called lofting, or was at some point in shipbuilding. I believe that's where loft came from. So that, let's see, did I want to hit anything else? I'll do one last piece, which is here. Let's delete that. Actually, I'm going to undo a bit so that we get that curve back to something I like more. I'm going to get rid of my little axis reference there. And let me go to the top view. Grab this curve. Let me purge history so we don't maintain any connections to things. Grab this curve. I'm going to bring it off to the side here. Let me actually go to a 4 view. And one interesting thing is that rather than go just the most simple thing, which I should say the most common, I won't do it right, the most common thing you see in the beginning of this type of surface modeling, often with NURBS modeling. And good question right now. Thin Man asks what program I'm using. I'm using Rhino 3D, but this applies to pretty much any 3D modeling software. A lot of this stuff is common. Interface will be different, names of things might be different, but this is something you can apply pretty much anywhere. So we looked at lofting from one curve to the next. We looked at this simple revolve, a single curve, and just sweep it around 360 degrees like you're on a lathe. We can go a little fancier with a technique called a sweep. So I'm going to make a rectangle with some rounded corners right here. And I'm actually going to move this rectangle by snapping its midpoint. Try that again. Midpoint to the end point of this curve. And now, unlike the simplicity of that revolve where you just give it an axis, it's a vector basically. In that case, I had a unit vector pointing z up the world. And so just whoop, sweep around it. Instead, in this case, I'm going to take my curve and use it as a profile to sweep around this rail, which is a more sophisticated shape. And it could be much more sophisticated than this rounded rectangle, but I'm going to keep it simple. And so what I'll do is say sweep. I'm typing in sweep 1. I have a single rail. It says select the rail. I'll pick this. Select the profile and hit enter. And you can see now we get a little more pizzazz, a little more shape to it. Went around that, that object there. I'm going to say OK to the default settings it wants. It, for various reasons, is giving me some asymmetrical geometry, which I could clean up, but I won't go into that today. But we get kind of a nice, neat shape here that we can, again, cap to create a closed object that we could 3D print. And we get the benefit of simplicity. Before I broke the, let's see if history is still on. I may have just broken the history. No, I didn't. Okay. So same sort of thing as with that previous object. We can go and adjust the shape of either of the curves and finesse things. Now, last thing I'll say is these techniques are usually related and sometimes even interchangeable. So if we wanted to, this could have been a loft. I'm just going to take this thing and duplicate some of the edges on it. Duplicate edge, select edges to duplicate. So I'm going to pick these edges here. And let's see, I think I have to duplicate iso curves. Hold on. I haven't done this way in a long time. Curve from objects. Extract ISO curves, how about? That should let me do it. Yeah, okay. Okay, so I've just taken a bunch of curves from this thing. I'm going to delete it. Delete my profile curve. So you could be thinking of your object this way. We could have started with that one rounded curve and made a little layer cake of them and do that loft command again. So if I pick these in order, loft, it's saying, okay, that's the direction and that's the start endpoints. Do you like that? I like that. We could fix those if we needed to. Hit enter, and now we're lofting a skin between each of those ribs. So, hey, funny, it's kind of the exact same result, nearly the exact same result, but created a different way. So you can use these techniques interchangeably. Often use the one you like most, the one you're most familiar with, or if something's wrong with the one you're trying, you may have a backup of another way to do it. But for me, in this case, this was probably the simpler way to do that. Okay, I think I'll cut that off there now. Let me check that I hit everything I wanted to. Yes, yes, yes. Split, join, fillet, revolve, sweep one. And even a little bonus loft in there. Okay, I think that is going to do it for that. Let me know in comments or Discord or elsewhere what you want to see. I have some basics that I'll be going through, but then we can get into modeling a real object, hopefully, and 3D printing it, making something that actually fits with one of our products so that we can do some precise measurement. One trick I really love is bringing in 3D models that already exist from our CAD library that the Ruiz brothers have made, which are usually made from the original PCB files, so they have dimensional accuracy, and then it's a great reference for building something around it. I do that all the time. Okay, that will do it for the 3D modeling and CAD segment today. I think that's going to do it. So thanks everyone for stopping by. I believe pending no sudden appearances of brand new human babies, Scott will be doing a deep dive tomorrow. Tune in to see if Foamy Guy has any plans for some live streaming as well. You can check the live broadcast chat and live broadcast announce as well as our blog. And then we will be looking for a Desk of Lady Ada sometime in there, a return on Tuesday of another product pick of the week, and Wednesday 3D Hangouts, and Show and Tell, and Ask an Engineer, and more. Loads and loads of stuff over on all of the Adafruit channels. I think that wraps it up. Did I miss anything? Did I forget anything? That was it. That's all I wanted to do. Okay, thanks everyone so much for stopping by for Adafruit Industries. I'm John Park. This has been John Park's Workshop. Bye-bye.
Thank you.